Find the equation of the tangent line to the curve xy plus natural log xy squared equal to 1 at the point 1, 1. The way we're going to solve this problem is by using implicit differentiation to find the slope of the tangent line. So let's take a look. Actually, first, let's check that our point actually lives on the curve. So if I put 1, 1 in for x and y, we notice that we have 1 times 1 plus natural log of 1 times 1 squared. Natural log of 1 is 0, so we have 1 plus 0. And we want to know, is that equal to 1, which is on the other side? Yes, it is. So this point, 1, 1, actually lives on our curve. Let's recall how we do implicit differentiation. So the idea is, if I have an equality, taking the derivative of each side of that equality with respect to x results in another equality. So when I start taking derivatives with respect to x, the first thing we note is we're going to treat y as y of x. Y is going to be a function of x, which means we'll need to use the chain rule. All that means, though, is if you differentiate y, it's just going to turn into y prime. The next step is to separate the y prime from the non-y prime items. We'll put each on different sides of the equal sign. Once we've done that, we can pull the y prime out of its side, and then we can divide to get an answer. Let's go to work. Okay, so I start off with x times y. I want to take the derivative of that with respect to x. So that's going to be the product rule, which will turn into y plus x. And I'm taking the derivative of y, so that just turns into y prime. For the derivative of natural log xy squared, the rule here is whatever's in the inside of natural log goes to the bottom, and then we put its derivative on top. We'll get to that in a second. Then on the other side, I'm going to take the derivative of 1 with respect to x. That gives me 0. Now, it's just a matter of expanding this derivative in the top and then just crunching away. So here, again, we're going to use the product rule. The x goes away, leaving me with a y squared. And then when I take the derivative of the y squared, that's going to come down to 2y. Derivative of the inside is going to be just y prime. So we get 2x y prime. And now I can just start dividing into this to clean this up. So this term comes as it is. Y squareds go away, giving me a 1 over x for this one. And then over here, the x's go away, and one of the y's goes away, leaving me with 2y prime over y equal to 0. So now we're going to collect all the y prime stuff on this side and push all the non-y prime stuff to the other side. So that'll give me this. I could factor a y prime out of this here, which is going to give me x plus 2 over y. Divide by that, x plus 2 over y, we put it in the bottom, and this gives me my formula for y prime. Now we want the point 1, 1, so I stick that in for x and y, and that gives me minus 2/3. We have everything we need for a tangent line. I have the slope, and I have a point. So our rule is y minus y0 equals slope x minus x0. So we have y minus 1 equals minus 2/3 x minus 1 for my tangent line.